Hello, so we've been asked to find the value of 8 125ths, all raised to the power of negative 2 over 3. Now that looks really difficult, but just break it down into sections and use the laws of indices, which I'm going to remind you of, and you'll be fine. So, let's just do a quick thought experiment. Let's suppose we have 2/5 raised to the power of 3. Well, that's just the same as 2/5 times 2/5 times 2/5. Anything raised to the power of 3 is just itself multiplied 3 times. So 2/5 by 2/5 by 2/5. Okay? And when we multiply fractions together, that's nice and easy because we just multiply all the tops together and then we multiply all the denominators together. So multiply the tops together, we get 2 times 2 times 2. And multiply the denominators together, we get 5 times 5 times 5. Can we simplify that using indice notation? Yeah, absolutely we can. 2 times 2 times 2 is just the same as 2 to the power of 3, isn't it? Because we're multiplying 2 by itself 3 times. And so similarly with the denominator, we're multiplying 5 by itself 3 times. So we end up with 5 to the power of 3. So let's look at where we started and look at where we finished. So we had 2/5 to the power of 3 is equal to 2 to the power of 3 over 5 to the power of 3. So look where the indice started and look where it ended up. We started with the indice outside the brackets, and then we ended up with the indice next to each term in the fraction. So in other words, what we can say then is that this thing up here, which we're trying to work out, is just the same as 8 to the power of negative 2 over 3 over 125 to the power of negative 2 over 3. Now, you're probably saying, hang on a minute, that looks far worse than when we started with, because we've got more negative 2 to the power of 2 over 3s. But just treat this sort of fraction, this line in between the fraction is a vinculum. That just really means division. So I'm actually just going to rewrite this fraction as 8 to the power of negative 2 over 3 divided by the 125 to the power of negative 2 over 3. So that's just the same as that. Okay. Now that's looking a little bit more like something we can handle than this, right? But we can actually go further. So let's suppose we have, for example, 2 to the power of negative 4. Well, 2 to the power of negative 4, what do we do here? We just do 1 over 2 to the power of 4. We make the negative mean 1 over, okay? And then we just take the positive version of it. Just take the positive version of it. So it's 1 over 2 to the power of 4. So if we just do the same thing here, so we've got negative 2 over 3. So if we just make it a positive 2 over 3 and stick 1 over, and same with this one. So we've got 1 over that as well. So we've got that divide. Okay, so what do we do now? Well, we're dividing fractions. I can totally divide fractions, because all I do when I divide fractions is I flip this one, and I turn this into a multiplication. So if I flip this one, it becomes 125 to the power of 2 over 3, and I've got a 1 on the bottom. Okay, and I'm multiplying the fractions together, so the numerators just multiply. The numerators just end up multiplying, and the denominators just end up multiplying. So it just becomes 125 to the power of 2 over 3 times 1. So I just end up with 125 to the power of 2 over 3. And then 8 times 1 is just 1. So that's my new fraction. That's my new fraction. Now, okay, that's not necessarily looking that much nicer, but all I have to do then is just remember what I did in the last video. So just remember that if I had, for example, 8 to the power of a third, for example, 8 to the power of a third, and then if I multiply that by 8 to the power of a third, then if I multiply that by 8 to the power of a third, okay? Well, because it's the same base, then I just add the powers together. So I've just got 8 to the power of a third, plus a third, plus a third, right? Plus a third. So a third plus a third plus a third, that's 1, isn't it? So that's just 8 to the power of 1, right? So 8 to the power of 1, which is just 8. Okay, but what does this really mean? Are you happy I'm just multiplying 8 to the power of a third by itself 3 times? So I can just simply say that's 8 to the power of a third all cubed. So I can say that 8 to the power of a third all cubed is just 8. Okay, I don't want 8 to the power of a third all cubed. I just want 8 to the power of a third. So to get rid of this cube, I just cubed root. So this is equal to the cubed root of 8. This is equal to the cubed root of 8. But you're probably saying, hang on a minute, I haven't got 8 to the power of a third, I've got 8 to the power of 2/3. Well, what does 2/3 actually mean? What does 2/3 actually mean? Well, 2/3 is just equal to a third plus a third, right? A third plus a third. So if I have 8 to the power of 2/3, so I'm going to leave that for a minute. So if I've got 8 to the power of 2/3, then that's just equal to 8 to the power of a third plus a third, because that's how I make my 2/3. So if I write that a bit better, that's how I make my 2/3, right? So what is 8 to the power of a third plus a third? Well, I'm just really using a law of indices in reverse, right? If I have 2 to the power of 3 multiplied by 2 to the power of 4, then that's just the same as 2 to the power of 3 plus 4. So in other words, I can say when I add the powers, it just means that I'm multiplying those two things together. So this is just literally the same as 8 to the power of a third times 8 to the power of a third. Well, are you happy then that 8 to the power of a third times 8 to the power of a third, I'm just multiplying the same thing together twice, so I can simplify that using indice notation as just 8 to the power of a third squared. So, and I've just said that 8 to the power of a third, 8 to the power of a third is just the cubed root of 8. So actually that is just equal to the cubed root of 8, all squared. And I can use a similar kind of argument for the numerator. So actually this whole thing here is just equal to, well, I'll do the 8 to the power of a third, 2/3 first. So I've got 8 cubed root of 8 all squared. And a similar kind of thing for the numerator. I've got 125 cubed rooted all squared. Okay. Well, I suppose the next question is, what actually is the cubed root of 8? So what actually is the cubed root of 8? And what actually is the cubed root of 125? It's the cubed root of 125. Well, the cubed root of 8, and basically what I'm looking for is a number times itself 3 times, okay, should equal 8. Because in other words, you know, if I'm timesing it by itself, that's just basically saying that that number cubed should equal 8. Well, what is that number? Well, let's try 3. Let's try 3. So what is 3 cubed? So that's just the same as 3 times 3 times 3, right? So 3 times 3 is 9. Well, already we're way too big. So we know it's not 3. We know it's not 3. So can we think of another number? Well, let's try one less than that. So let's try 2. That's just 2 times 2 times 2. So 2 times 2 is 4. Times 2, that's 8. Yeah, so it's 2. So I can just simply replace that with 2. Cool. Okay. What about cubed root of 125? Cubed root of 125. Cubed root of 125. Well, the thing is, if it ends in a 5, so remember what I'm looking for. I'm looking for a number which multiplied by itself 3 times, so a number cubed, basically. A number cubed, which when multiplied by itself 3 times should equal 125, right? Well, if it's equal to 125, then the end digit is a 5, which means that the number which I'm looking for is probably going to be a 5, right? It's probably going to end in a 5 at least, because if it ends in a 5, then it means it's a multiple of 5. So let's try 5. Let's try 5 cubed. So 5 times 5 times 5. Well, 5 times 5 is 25. What's 25 times 5? Well, I can convert 5 into a fraction, just being 10 over 2. Okay, and likewise, I can convert my 25 into a fraction if you want. It's 25 over 1. So 25 times 10 is 250. But then I've still got to do 2 over 1, 2 times 1, so that's 2. So 25 divided by 2, that's 125. Way! There we go. So I can just say that the cubed root of 125 is just 5. But look what I've got to do now. I've got to do 5 squared. That's fine. I can totally do that. That's the easy part. Okay. And then I've got 2 squared on the bottom. So that's 4. So I've got 25 over 4 as my final answer. That wasn't that bad, was it?